This is the second video to do with amines from the A2 chemistry spec. So you should have already looked at video 1, which is to do with the naming of the amines, the classification of them in primary, secondary, tertiary amines, and finally the physical properties. So in other words, the melting points and boiling points really is what we looked at. Okay, so the preparation of the amines, you'll find this on page of your textbook, page 211. So you need to make sure that you've done the page 211 of your textbook, and then that runs through to page 214. So you need to read through that, okay, and you need to make sure you've had a go at the exercises there, okay. So that is what we're going to look at today. Okay, so you have a couple of methods here for making amines. You've already looked at one of them in AS chemistry, whether you can remember it or not. Okay, so it is the nucleophilic substitution of a haloalkane. So we take that haloalkane with excess ammonia. So usually we would refer to that as concentrated ammonia. It's done in ethanol. Remember, haloalkanes don't dissolve in water, so ethanol, as you hopefully can remember, is our solvent in this context, and we heat it under pressure. We don't heat it under reflux because ammonia is a very volatile substance, will turn into a gas and be lost under reflux. So this is the one that we heat in a sealed container under pressure. Okay, and there's your general reaction for it there. Okay, now you can also write it just exactly the same thing. 1 ammonia to give you, in this case it would be hydrogen bromide, not the ammonium bromide. So either of those would be fine. Okay. The problem with this preparation is it gives you some secondary, some tertiary, and we're not worried about quaternary amines. So it gives you a mixture of amines. Now we use excess ammonia to do our best to minimize the number of secondary, tertiary, and quaternary amines. If you look at the title of the slide here, we're trying to make primary amines. Okay? So we do our best to avoid having any of the secondaries, the tertiaries, and that's the reason why we use excess ammonium. I'm not going to go into the reasons as to why that helps to avoid that. Okay, you just need to know that that's what it does. If you want to find out why, you can look that up elsewhere. Ethanol, we said earlier, avoids hydrolysis. So if you did have water as your solvent in here, okay, you would end up getting some alcohol produced as well. Okay, so obviously you don't want that. So just pause the video briefly there and tell me what compound would you start off with if you wanted to make 2-amino propane or propan 2 amine. Okay, so yes, you would use a bromo, but you've got to make it specific that you use the bromo with the BR on position number 2. And use excess ethanolic ammonia, and there's your equation. Okay, remembering that your NH2 group is on the middle this time. Okay, so there's 5.9G. We'd like to have a go at 5.9G, guys. You can either pause the video or you can go to your textbook and do it. Right, the second method then is reduction of nitrites, which is a new one too. We haven't done that yet. So we take our haloalkane and we convert that initially to a nitrile. Now this is AS2 reaction, if you can remember it. So it's nucleophilic substitution by heating the haloalkane with potassium or sodium cyanide, again in ethanol, and again the ethanol is to avoid hydrolysis and the formation of an alcohol. Okay, right, so we've now got our nitrile group, and remember our nitrile group will be wherever our original BR group is. Okay, we then reduce that nitrile group. Now there's a few ways of reducing it. You can use hydrogen with a nickel catalyst. The one that's on the CS specification is this compound called lithal. Now we've met lithal before, LiAlH4. It is done in dry ether because lithal reacts violently with water, and it is followed by the addition of dilute mineral acid, so dilute hydrochloric acid, dilute sulfuric acid would be 2 that you could choose, and this is followed by not with or at the same time as. Okay, so just watch your wording there. Okay, and it has to be in dry ether. Don't just say lithal, please, and certainly don't say lithal in water. Okay, now what you will notice here, and this is where you need to be careful when you're answering questions on this, when you add a cyanide ion, okay, and you form a nitrile group, you add one carbon to the original chain. So in other words, let's say down here I wanted to make this compound, which would be ethanamine. I would have to start, if I was going right back to the start, I would have, sorry, ethanamine, yeah, ethanamine, sorry. You'd have to start here with a meth, okay? So it'll be a meth, it'll be a bromo, so we simply bromomethane would be what you would start with here. So bear that in mind if the examiner gives you an amine to make via this route, and you've got to go back to the original haloalkane, remember to take a carbon off. Alternatively, if they give you the haloalkane and they ask you what would the name of the amine be that is made via this synthetic pathway, you have to add a carbon on. Okay, now the good thing about this is that it only makes the primary. You have no contamination of secondary, tertiary or quaternary amines in this process. Okay, it makes exactly the pure primary amine. Okay, so pause the video and have a go at 5.98, or alternatively go to your textbook and do it. Okay, there's question 3 on it. Okay, and then finally, if you wanted to make 1-amino butane, okay, so the trap there was just to remind students that they had to start off with 1 bromo probe. So not only did they need to be specific about the number 1, but they had to recognize that it was probe. Okay, and then we take our butane nitrile, reacted with lithal and dry ether, followed by dilute hydrochloric or sulfuric acid, and we get our product. Okay. Okay, so the last video looked at making, or no, the last video, the first part of this video looked at making primary aliphatic amines. Okay, this video, the second part of the video is going to look at making, or the preparation of primary aromatic amines. So, just to remind you, aromatic or benzene related compounds, so you'll have a benzene ring in these ones, whereas the aliphatic ones were ones which were straight chained, okay, or branched, but they weren't, there was no benzene ring in them. So believe it or not, this is a different process altogether in making these, so you need to be careful and read the question and make sure you're making an aliphatic or are you making an aromatic amine. So NH2 groups cannot be placed directly onto a benzene ring. Ammonia that we would use is of course a nucleophile, and benzene reacts, as you know from your benzene topic, with electrophiles. So that is simply not going to happen. The energy requirement to do that would just completely prohibit that occurring. So a nitrobenzene compound is made first, right? When you did benzene chemistry, you worked out how to, or you learned how to turn benzene into nitrobenzene. We'll look at the conditions of that in a wee second, but you've already done the chemistry behind that. We then reduce that nitrobenzene to form amino benzene, or phenylamine as it's also called. So you have 2 steps starting with benzene here. You have a reaction 1 and then you have a reaction 2. Okay, so nitration followed by a reduction. The reduction here, usually when we're reducing things at A level, we use good old reliable lithal. This time we do not use it, so please learn your reducing agent carefully. We use this time tin with conc HCl, 6 molar HCl we have here, and we heat that under reflux. So those are your reactant conditions for step 2 that I spoke about here. That's your reducing agent. So step 1 is the electrophilic substitution with the nitric acid less than 50 degrees Celsius to give me nitrobenzene. That's the first thing I do, trying to make amino benzene or phenylamine from benzene. Okay. Step 2 is the reduction of that nitrated compound that we've just made in step 1. Okay. Now we use H in square brackets to represent the reducing agent. We need 6 of them per NO2 group, so yes, please be aware of that. If it was a dinitro, you're going to need 12 of these. Okay, and we get our final product, which is amino benzene or phenylamine, more commonly called. Okay, and 2 waters. Alright, so you need to learn that obviously. Now, we need to look at this a little bit more detail of the reduction of the nitrobenzene. So the first thing that happens to the nitrobenzene that's made from step 1 in the previous slide is our tin provides electrons, so that's the reason for the tin. Okay, and of course our HCl is the source of hydrogen ions. And when we do this, we end up getting the ammonium ion. Okay, the ammonium ion of benzene. Now, we remember what we've got to do here is we've got to convert that ammonium ion into phenylamine or aminobenzene. So how do we do that? Well, in order to go from there to there, you've probably realized I've got to remove a hydrogen and I've got to remove a plus charge. So in other words, I've got to remove an H plus. Now, how do I get H pluses removed? Well, I use alkali. Alkali are proton acceptors. They accept H pluses. So therefore, the OH minus ion here, probably from a source like sodium hydroxide, I add it, it takes the H plus off and forms water, and I'm left with my phenylamine or my aminobenzene. So this is a deprotonation reaction, okay, and it is the way in which we get, so this is the salt, okay, of the aminobenzene, and this is now what we call the free base. We've now got the free base, which is the, in this case, aminobenzene or phenylamine. Okay? So, and this process is called, and you might read it in questions, how to liberate is a word you might get, liberate the free base. And we're liberating it from the salt. Okay? So bear that in mind because you will get questions about this. Okay? So to liberate a free base from the salt, we use alkali. Okay, so again, you've got some questions, 5.9i, I think that is. So just pause the video or go to your textbook. Okay, so that's a video, guys, on the preparation, and that should take you up to, where have I got you there? Page 213 of the notes is as far as I've got you. Okay, so that takes us to page 213, sorry, of the textbook. Okay, and I started there today at the preparation, which was page 211. So our next video will be on the acid-base, or the basic properties of amines. Okay, so there you go. Hopefully that helped you.